Okay, so yesterday we talked about graphing the hyperbolas and finding all the pieces. Today what we're going to be doing is given pieces of it, and then we're going to write equations. So go ahead and get to that slide. We already did all of these. So here, this is going to be what the steps will follow. So when we want to find the equation of a hyperbola, we're going to use the given information to determine first if the hyperbola is vertical or horizontal. So if it's got a y squared or an x squared, we're going to be finding the center. We're going to be finding the a and the b values. Remember this time the c squared equals a squared plus b squared. And again, the vocabulary word that's tied to our book, they call the transverse axis, or the axis that our graph is going to be crossing, is going to be equal to 2a, and it's called the transverse axis. The conjugate axis is going to be set equal to 2b. So again, remember the transverse axis is what it's either going to touch or cross, or almost like run parallel to. So let's go ahead and take a look at our first example. Again, if it helps you to give yourself a visual, that would be a clue of which axis it's going to be touching, so we'll know which variable to write first. So again, if I graph my two foci, they're going to be at -3, +3. 1, 2, 3, 1, 2, 3. So they are located right here. These are my foci. And then I have vertices also located at -2, +2. So we can see that our hyperbola is going to look like this. Notice it's transversing the x-axis. It's horizontal. So my equation that I'm going to be filling in is, since it's touching the x squared, or the x-axis, I'm going to put x squared first. Remember, a squared is always first. The hyperbola equation has a subtraction sign, and then the y squared over b squared equals 1. Now, to find all of the values here, I need to find a squared and b squared. Now, what's given to me, though, is a vertex and a focus. So remember, the a value is going to be the distance from the vertex to the center. And the c value in this problem is going to be the distance from the focus, or the foci, to the center. So, and again, that center is the midpoint between the two vertices, or the midpoint of the focus points. So I can see my center point here is at 0, 0. That's why I had this equation. There's no h and k here. My h and k are 0. So I can count the little spaces, or I could subtract here. I can see that my c value, the distance from the green to the blue, my c value here is going to be 3. So from here to here, focus to center, c is 3 spaces away on both sides. And then the distance from the vertex to the center, my a value is 2. So a equals 2. Or plus and minus 2 here in both directions. And then a squared equals 4. And then c squared, or c, let me do the c first. C was equal to plus and minus 3. So c squared equals 9. Now, I don't need c squared for my formula, but I need to use the c value to find b. And I'm using c squared equals a squared plus b squared. So c is 9, a was 4. I don't know the b squared, so I'm going to subtract 4. 5 equals b squared. I don't need to square root it because I need b squared in my formula, or my equation. So I'm just going to fill in my a squared and my b squared. So my final answer here, the equation, is going to be x squared over 4 minus y squared over 5, and it equals 1. Again, remember, when the center is at the origin, we can see that this focus point here, the foci, this is really negative c, comma 0, positive c, comma 0 when it transverses the x-axis or it's horizontal. And then my vertices here, this was negative a, comma 0, positive a, comma 0. This is with the center at 0, 0. Let's try another one. Again, it really helps to do the visual. Next example, again, give myself a visual. I have vertices at positive 1 and negative 1. So my vertices are here. It's telling me I have an asymptote of y equals negative 4x. Now, this is showing me that my graph is going to be transversing the x-axis. And remember, when it's horizontal, your asymptote is equal to y is equal to plus or minus b over a. So what I'm going to do is I'm going to set up a proportion. And I can show that b over a is equal to 4 over 1. And this is plus or minus here. Now what I can do is, since I already knew that the midpoint of these two vertices, the center point is 0, 0, and I can see that my a value is going to equal 1, so a squared is equal to 1 as well. So notice this was set up appropriately. So I can go ahead and cross multiply here. And since a equals 1, I could put b over 1 equals 4 over 1, which is going to show me that b is equal to 4. And then b squared is going to equal to 16. So now let me fill in. So again, since it was touching the x-axis or it's horizontal, I'm doing x squared over a squared minus y squared over b squared equals 1. X squared over 1 minus y squared over 16 equals 1. Now, realize probably you should also recognize that we don't need to write that 1. We could just leave it as x squared minus y squared over 16 equals 1. So be aware that both of these are valid answers. Always remember, a squared is always the denominator of the first fraction. Again, I'm going to give myself a visual. If you can already see it, you don't need to do this. But I can say I've got a vertice, oh no, sorry, this is a focus at 0, 5 and 0, negative 5. And again, the midpoint between those two foci is the center, and that's going to be 0, 0 again. My C value, remember, is the distance from the vertex to the focus. So my C is 5. So C squared is 25. I'm also given an asymptote. Now, remember, my hyperbola, the focus or the foci are also on the same axis that the vertex is. So my hyperbola would look like this. So it's transversing the y-axis. So I'm going to be filling in y squared over a squared minus x squared over b squared equals 1. Remember, when it's transversing or it's vertical, the asymptote is going to be y equals plus or minus a over b. So again, I can go ahead and set up a proportion here. I can take a over b, set that equal to the 3/4. And then now I can go ahead and solve this proportion. Now, I don't know anything about a or b, so I'm actually going to have an answer here with two variables in it. So I'm going to take and do the cross products. 3 times b, a times 4. You can solve for either a or b. It doesn't matter. I'm going to solve for b. So I'm going to go ahead and get 3b is equal to 4a. I'm going to divide both sides by 3 because I'm trying to isolate b, and I get 4/3 a. Now what I need to do is I need to take this information and I need to plug it into c squared equals a squared plus b squared. Well, I know my c squared is 25. I don't know a squared, and I just found the value of b to be 4/3 a. And I have to square that. So then this becomes 25 equals a squared, and then this becomes 16 over 9 a squared. I now need to combine my like terms. I'm going to go ahead and change this 1a squared into 9 over 9 a squared. So I have a common denominator. And I get 25 over 9 a squared equals 25. I need to isolate a squared. So I'm going to divide by 25 over 9, which really means multiply by the reciprocal, because then this cancels. Write the same thing over here, and then this simplifies, and I get 9 equals a squared. I don't need to square root it. I'm going to use that now to find b. So now that I have a, I can go ahead and plug it right back into this thing again. My c squared was 25. I just found a squared to be 9. Subtract. And b squared equals 16. Now that I have a squared and b squared, I can plug it back into my equation. So my final answer here is going to be y squared over a squared, which is 9, minus x squared over b squared, which was the 16, equals 1. Now, for this one, I couldn't have just squared this because I don't know if this was a simplified fraction, which it was. So, or in this case, it wasn't. But sometimes it will be, and we're going to see that coming up. All right, let's try the next one. All right, next one. Again, I'm going to give myself a visual. Graph the vertices. A vertex at 0, -2, and 0, +2. This time it's telling me it's passing through the ordered pair -2, +5. So this would tell me that my hyperbola is going to be looking like this in order to get to this ordered pair. So this ordered pair, remember, is going to be x and y. I could also see that my center point here, the midpoint of these two vertices, is 0, 0. So since it's touching the y-axis or transversing it, I'm using y squared over a squared, x squared over b squared equals 1. Now I can find my a value. It's the distance from the vertex or one of the vertices to the center. A is 2, so a squared is equal to 4. Now, I don't know anything about b or c, so I can't use the formula c squared equals a squared plus b squared. I'm going to plug in my given information into my standard form here. I'm going to use my x and y value from that point that the graph passes through. So my y value was 5, so 5 squared. My a squared I found to be 4. My x value from that ordered pair is going to be -2 squared. I don't know b squared equals 1. So I'm solving for b squared. So this turns into 25 over 4 minus 4 over b squared. I need to isolate b squared. So I'm going to subtract 25 over 4. I'm going to change the whole number 1, and I'm going to make it 4 over 4. So I have a common denominator. So then I'm left with negative 4 over b squared equals negative 21 over 4. Now, whenever I have something like this, two fractions equaling each other, I'm going to solve this as if it's a proportion. Now, we could multiply both sides by 4 or the b squared, but again, it's a lot easier to just cross multiply. So I'm going to multiply the b squared times the negative 21, and then negative 4 times the positive 4. And then this is going to give me negative 21 b squared equals negative 16. Divide by negative 21, and b squared is equal to negative divided by a negative, positive 16 over 21. Now remember, all we need to find is a squared and b squared. So I found that. So now I'm going to go back to what I said the standard form was that we needed to fill in. So y squared over 4 minus x squared over 16 over 21 equals 1. Now, some standardized tests let you leave it like this. Others are going to make you take this denominator and move it to the top. So the other way that you could represent this answer is y squared over 4 minus 21x squared over 16 equals 1. Be aware of both forms. Essentially what we're doing to move the 21 to the top is we're dividing x squared by 16 over 21. And you do a key flip change. So essentially what all we did, and you don't need to do that to do this, just know that you take the denominator and move it to the top. Essentially what we've done is divided this fraction and then do a key flip change. Flip it, and that's how it turns into 21x squared over 16, which is what I wrote for that equation. All right, so if you had opened up the initial notes from when the course was set up, this is where the notes stop. However, the notes are going to continue. There are more examples that have been added. So if you had opened up prior versions, you'll just handwrite them in. So here is example 9. Again, I'm going to give myself a visual. Still the same idea here. So here is my x and y axis. I have x-intercepts at positive 3, negative 3. So I've got a point here and here. And then I have focus points or foci at positive 5, negative 5. So this x-intercept that's here is actually the vertex. And these are the foci. So you can see that your graph is going to look like that. And again, we can figure out that, again, the midpoint between those two x-intercepts or the midpoint between the foci, the center point is at 0, 0. So again, because it's crossing that x-axis, my equation I'm going to be filling in is x squared over a squared minus y squared over b squared equals 1. Now I can find my a value by seeing how far away that vertex is from the center. And I can see that it's 3 spaces away. So I can say a equals plus and minus 3. So a squared is going to be 9. And then the c value is the distance from the center to a focus. And we can see from here, it's going to be 5. So c is plus and minus 5. So c squared is 25. So now to find b squared, which is all I need to always find is a squared and b squared, I'm going to use the equation. C squared equals a squared minus or plus b squared. Fill in what I know, 25, 9, and then leave the b squared. subtract 9, 16 equals b squared, and now I have enough information to fill in the bottom of my standard form here. So again, it's x squared over 9 minus y squared over 16, and it equals 1. Now, sometimes when you see zeros in the given information, you might not need to give yourself a visual. Again, it's totally up to you whether you need it or not. Let's try number 10. All right, number 10. I'm going to go ahead and again give myself a visual. And my y-intercepts are at 0, 9 and 0, -9. And then I have foci here way off of this thing at 0, 15 and 0, -15. So you can already see that your hyperbola is going to transverse, it's going to be vertical. So again, the distance, so again, the midpoint between these two y-intercepts is 9, which is the a value. And then the distance between the foci, the c value, is 15, or plus and minus on both of these. So again, since it's touching the y-axis, I'm using y squared over a squared, x squared over b squared equals 1. Now, I'm using c squared equals a squared plus b squared because I have c, which is 15, and 15 squared is 225. And 9 squared is 81. So 225 equals 81 plus b squared. Subtract 81. And I get 144. Again, I don't square root it because I need b squared. So I'm filling in b squared and a squared. So final answer, y squared over 81 minus x squared over 144, and again, always equals 1. Now, notice all of these were at the origin. Again, examples 11 and 12 are still having our center at 0, 0. We will get to some examples where they're not. I know I haven't done a whole lot, so there is an additional video with more problems where the center is not 0, 0. But let me just keep going here and quickly get through the last couple examples. So just know there is a video already on YouTube with additional examples where the center is not at 0, 0. So here, let me go ahead and give myself a visual. I've got vertices at -10, +10. So here is my vertice. And again, you can see that the vertices are transversing that x-axis. So the equation I'm going to be filling in is x squared over a squared minus y squared over b squared equals 1. Now, whenever the transverse axis is the x-axis, your asymptote is going to take on the form of y equals plus or minus b over ax. So I can find my a value. It's the distance from the center to each of the vertices. And you can see that the a value is 10. So a squared is going to be 100. So now, I don't know anything about c, so what I need to do is plug it into the asymptote. So I'm going to take y equals the plus or minus b over a. So I'm going to take the b over a and then set that equal to what I have. So B over A, and that's going to be set equal to 5 over 1, because that was the number that's here. And then I also know my A value. So I can plug in a 10 now for the A. And now I can cross multiply to get B. So B times 1, 10 times 5. My B value is 50. So B squared is 50 times 50, or 50 squared, which is 2,500. I now have my A squared value and my B squared value. All I need to do is plug them in. So final answer, x squared over 100 minus y squared over 2,500, and it equals 1. Let's try example 12. Okay, so for number 12, again, give yourself a visual if you need it. Vertices at 0, 5 and 0, negative 5. These are the vertices. You can see its midpoint is 0, 0, which is the center. And then you can see your A value, distance from the center to the vertex is 5. So A squared is 25. And again, they're passing through an ordered pair here. And we can see that this is going to be x and y. So we can see that to get to 310, it would go up this way and this way. So again, the equation I'm using is x squared over a squared minus y squared over b squared equals 1. I'm going to fill in what I know. So I have my ordered pair. I'm going to use that for x and y. So I'm going to put in 3 squared. Nope, sorry, I wrote the wrong equation. Back up. It's touching the y-axis, so y squared needs to be first. So 10 squared over 25, because it's already got the 5 squared in there. And then x is 3, so square 3. And I don't know b squared. So I get 100 over 25, 9 over b squared equals 1. Now, I'm going to go ahead and simplify 100 over 25 and make it 4. And it's going to make my problem a little bit easier maybe to solve. I can subtract 4 from both sides. Negative 9 over b squared equals negative 3. And then I'm going to solve this as a proportion. I'm going to add a 1 to the negative 3. And then I'm going to do the cross products. So this times this times this. So then I get negative 3b squared equals negative 9. Divide by negative 3. And b squared equals positive 3. I don't need to square root it because I need b squared and I need a squared. So then I just plug them in here and here. Y squared over a squared, which is 25, minus x squared over 3 equals 1. And I'm done. Try the next example. Almost done. All right. Example. This time they gave me the foci and an asymptote. So foci, again, you could just approximate it. Know that it's here, 3 root 5, comma 0, negative 3 root 5, comma 0. And then my asymptote, so you can see that these are the foci. So the vertices are going to be somewhere here. And what we can do is, since it's touching the x-axis, this tells me that my asymptote is taking on the equation b over a. So now I'm going to go ahead and fill in what I know. So I have b over a is equal to 2 over 1. And I can also see that my C value, again, here's the center, it's at 0, 0 still. And the equation I'm filling in is going to be the x squared because it's crossing the x-axis. So the equation I'm filling in is x squared over a squared minus y squared over b squared equals 1. Now my C value is the distance from this focus to the center, and you can see that it's 3 square root 5. So that's what C equals, plus or minus. When I square 3 square root 5, I square the 3, and then when I square the square root of 5, that just becomes a 5. So C squared equals 45. So now, let me go ahead and fill in. Actually, let me solve for A over here first. I need to get it in terms of something that I can plug in. So again, I'm going to cross multiply here. And I get 2A is equal to B. So I'm going to take what B equals, and I'm going to plug it in to C squared equals A squared plus B squared. So I'm going to put 2A here and square it. My C value is, C squared is 45. So 45 equals A squared plus 4A squared. I can add my like terms here, becomes 5A squared. Divide by 5. 9 equals A squared. I don't need to square root it because what I need is A squared and B squared. Now I got to plug it back into the equation one more time. C squared equals A squared plus B squared. Now that I have C squared and A squared, I can plug those numbers in and get B squared. So C squared again was 45. A squared is 9. And I'm solving for B squared. So subtract 9. 36 equals B squared. Now that I have B squared and A squared, I can plug them both in to the equation. So final answer is going to be x squared over 9 minus y squared over 36 equals 1. One more example. This time the center is not going to be at the origin. Now I do realize this is only going to be one example where the center is not at the origin. Again, I've got a video on YouTube that has a couple more examples where the center is not at the origin. So you can watch that. And then this way we'll have time to go over your quiz. So let's go ahead and do one example where the center is not at 0, 0. The vertices are at 5, -2 and 1, -2. Let me give myself a visual. 1, 2, 3, 4, 5. 5, -2. 1, -2. These are your vertices. So we can already see that the midpoint of these two ordered pairs, we can go ahead and just subtract the 2, or you can do the midpoint formula, but you're doing 5 plus 1 divided by 2. So then here it's going to be right here. The midpoint or your center point divided by 2 is 3. So your center is going to be the ordered pair 3, -2. That's going to be your center point. Now, you can also see your A value is the distance from this center to the vertex. So you can see that your A value here is going to be 2. So A squared plus or minus 2. So A squared is going to be 4. And now in this equation here, whenever it's transversing the x-axis, remember for your asymptote, this is B over A. So this was actually y equals K plus or minus B over A, x minus H. So again, you could have pulled your center out of this as well. So your center point is 3, -2. And now what I can do is B over A is equal to this, 3 over 2. Now I can already see that my A value is 2. So I can go ahead and substitute this A with a 2, and you can already see that your B value is going to be 3. Because B over 2 equals 3 over 2. And already, without even cross multiplying, it's an equivalent fraction, it's the same thing, but I'll cross multiply. 2B times 6, or equals 6, divide by 2, B equals 3. So B squared equals 9. So again, I need A squared and B squared. And this time I need my center point to plug into the equation. So let me go ahead and fill it in. So because it was transversing the x-axis, I'm doing x minus h squared over a squared minus y minus k squared over b squared equals 1. So let's fill it all in. X minus 3 squared over 4 minus y minus negative, so it's minus minus, so it turns into a plus 2, and then the b was 9. And that is it for the examples that are listed here. Again, if you want to see more examples where the center is not at the origin, there is a video on YouTube. So what we're going to do now is get back your quizzes, and we're going to go over the answers.